Hi, welcome to the testing of DC motors. Under that, have a classification of direct and indirect methods of testing of DC motor. So, under indirect test, let us consider the Swinburne test of a DC motor. So, this is the basic circuit diagram for a Swinburne test. So basically, this Swinburne test is conducted without applying load to this machine. If you look at this, we have a variable rheostat connected to the armature and variable resistance to the field also. So this figure 2 represents to measure the armature resistance by applying different voltage or to the machine, or by varying the resistance we can also calculate the RA value. So considering figure 1, so the procedure is as simple that this is an indirect or no load test performed on DC motors, in which in DC shunt motors we have said that flux remains practically constant, that is especially in case of shunt and compound. Without actually loading the motor, the losses and efficiency at different loads can be found out. So the first, initially the connections are made as shown in figure 1. The motor is made to run on no load at its rated speed by varying the armature resistance of the motor. So once we vary and see the speed as attained, the rated speed, say suppose 1500, then we make a note of it, the reading of ammeter and the values of voltmeter. So the no load current, that is A1, which measures the no load current, and the shunt current A2 is also measured, that is ISH. So using these two values, that is ISH is also given as V by RSH, and no load current IA naught is equal this IA naught to the armature will be I naught minus ISH. So IA naught is the current which is flowing in the armature, I naught which is read by this A1, and A2 is giving the value of ISH. So considering this, the power input to the armature is given as V minus I naught minus ISH. So the power input to the armature is also given as V into ISH, that is which is flowing in this field. Now no load power input to the armature supplies all the four losses, that is iron losses, windage losses, friction losses, and armature losses. Therefore, the constant losses is calculated as power input minus the armature copper losses. The armature current is IA is given as I minus ISH for motor and I plus ISH for generator. So, a Swinburne test conducting the no load, we can calculate the efficiency of a machine as a generator and motor. So, when we need to calculate the efficiency of a motor and generator, we need to know the difference of the current, that is IA, with respect to the load current I minus ISH, and for generator it is I plus ISH. Now efficiency of a machine when running as a motor. As I said, the input is given as V into I. So when the load is given, assuming the load is given, so armature copper loss will be IA square RA, where IA for motor is I minus ISH, as I discussed in the previous slide. So therefore constant losses is calculated, that is WC, by the test, and total losses will be I minus IS, that is armature copper loss plus the constant losses. Therefore the output of the machine is taken as input minus losses, where we know the input of a motor and the output is calculated based on input minus the losses here. So which is VI is the input minus, this is the armature, second term represents the armature copper loss, and the third term represents the constant losses. Now coming to the calculation of efficiency of a machine when running as a generator, as we know that generator, we normally know the output of the generator, which is given as VI. So armature copper loss will be I plus ISH square of RA, where constant losses is WC. Total losses will be this armature copper loss plus constant losses. Since we know the output of a generator, the efficiency will be expressed in terms of output, that is output by output plus losses, where we know the output as VI, and VI plus the armature copper loss plus the constant losses will result in the efficiency. So taking certain readings of the value, this is the no load values which is taken, that is V, I naught, IF, and speed at 1500. So this is the RA value. By varying RA and calculating the V and I, we can calculate the RA value and take an average of it for our calculation, RA average value. For different load, we need to calculate what is the output and what is the efficiency of a machine as a motor and efficiency of a machine as a generator based on the output and input of both motor and generator. So when we draw the graph and observing the calculation, we can see that the motor efficiency is always less than the generator efficiency. So no load input is given as V into I naught, and this constitutes constant losses. So the no load test, when we conduct, we determine the constant losses. So using that constant losses, we will calculate the efficiency as a motor and generator. So the equation goes like this, which I've already discussed. Thank you for watching.